The physical spaces where higher education traditionally happens are emptying out, replaced by distributed digital environments. And the tools students rely on have rapidly advanced. Recent data shows 95% of university students now report using generative artificial intelligence in at least one way. Drill down into that number, and 94% state they use AI specifically to assist with their assessed coursework. As a direct result, 65% of those students feel their assessments have already changed significantly in response to the technology. Yet the standard institutional response often treats these tools as a compliance issue. Administrators draft broad, discipline-agnostic policies that treat AI as a temporary assessment add-on, focusing heavily on what constitutes academic misconduct. They ask, can students use it, when the pedagogical reality requires them to ask, how should students use it well? When institutions offer vague guidelines without specific curriculum integration, they push students into what we call shadow AI, an undisclosed, hidden reliance on unapproved tools. A policy's location in a syllabus predicts its actual function. If AI rules exist only as warnings in an academic integrity handbook, rather than carefully designed learning outcomes, they will only drive usage underground. This matrix maps student AI behaviors across tool appropriateness and extent of use. In the bottom left quadrant, we see passive risk. Here, shadow AI behavior lives, characterized by undisclosed usage, uncritical reliance, and severe data vulnerabilities. This risk compounds in online and blended learning environments. Distance from campus and reduced accountability often push time-pressured learners toward AI as a shortcut for producing work, rather than a tool for engaging deeply. The required institutional destination is the top right quadrant, the AI literacy zone. Here, students draft with AI but actively critique the output. They verify summaries, check for hallucinations, and disclose their referencing. Migrating a massive student body from the shadow zone to the literacy zone requires a massive structural pivot in how we teach. Sustainable academic integrity relies on curriculum-embedded design that specifies exactly how students should interact with these tools. To bridge the gap between high-level university policy and daily classroom application, educators can use the Prompt Chaining Development Model, or PCDM. This vertical gauge models Bloom's revised taxonomy, giving us a reliable metric to measure the cognitive demand placed on a student, moving from basic recall at the bottom to original creation at the top. We map a second metric parallel to it, AI autonomy. This represents how much freedom the technology has to generate content or structure arguments. The PCDM operates on a single, unbreakable rule. The AI's autonomy can only expand if the student's demonstrated cognitive effort expands first. This interlocking constraint guarantees that AI acts as a scaffold for cognitive development, physically preventing the tool from short-circuiting the human learning process. At level 4, the undergraduate foundation stage, the primary academic goal is protecting a student's cognitive independence as they build core disciplinary knowledge. This linear flowchart illustrates the feed prompt chain, designed strictly for beginner learners requiring assisted access. It starts with focus. Before opening any software, the student must define the task and their objective in their own words. Next is engage independently. The student produces their own initial draft, outline, or calculation completely unassisted. The human effort happened here. Only then do they elicit AI feedback, asking the tool to identify gaps or weaknesses in their draft. Finally, they decide and reflect, choosing which critiques to accept, adapt, or reject, and explaining why. At this foundational level, the framework forces the AI to act strictly as a mirror for review, never as an author, ensuring the student achieves baseline competency on their own. Moving to level 5, the cognitive demand shifts upward to application and evaluation. The student's foundational knowledge is secure enough to withstand friction. Here, assisted access graduates to guided access. The AI is repositioned from a feedback mirror into a cognitive sparring partner. This branching dialogue tree maps the probe framework, a dialogic prompt chain designed to stress test ideas. First, the student must clearly state their position on an issue. They then explicitly prompt the AI to request a counter, ordering the tool to generate the strongest possible argument against their stated position. The student must observe critically, analyzing the AI's response to identify underlying assumptions, biases, and missing evidence. Finally, they build a rebuttal to defend their original stance and evaluate the shift, documenting exactly how the exchange altered their thinking. By obligating the student to defend their position against synthetic opposition, the probe framework turns the management of AI bias and hallucination into an active, rigorous learning exercise. At level 6, students reach the apex of Bloom's taxonomy. The requirement shifts to creating original, complex work. This funnel interface illustrates the craft chain, designed for autonomous access and strategic multi-layered collaboration. It begins by contextualizing the scope of a major project, followed by iterative, multi-step prompts to research with AI, gathering models, perspectives, and vast datasets. Because the inputs are broad, the student must meticulously audit outputs for reliability and partial truths, before filtering and synthesizing the strongest evidence into their final original argument. This maximum level of AI autonomy is permitted exclusively because the student has, through the previous levels, acquired the critical auditing skills necessary to orchestrate a complex research workflow without being misled by it. This mapping of cognitive demand to AI autonomy scales across the entire educational continuum. It scales downward to level 3 further education and vocational contexts, using the highly constrained TRACE framework to verify outputs against professional standards. And it scales upward to level 7 and 8 doctoral studies, where researchers use the Architect and Originate frameworks to synthesize entirely new systems. Regardless of discipline or degree level, these distinct prompt chains unify under a single conceptual umbrella. They produce what we call auditable cognitive effort. By requiring students to document their initial focus, their prompts, and their reflections on AI's output, the model leaves a highly visible trail of student reasoning. It satisfies complex regulatory and safeguarding requirements by proving the student did the thinking. This verifiable structure provides direct evidence of a student's critical engagement. Educators can focus their assessment on the quality of the student's orchestration and the intellectual rigor of their synthesis. The uncritical reliance on generative outputs, rather than the existence of the technology itself, creates the primary risk to modern education. Attempting to ban a universally adopted technology fails to protect learning outcomes, and broad compliance warnings simply mask the problem. The prompt chaining development model accepts the presence of the technology, but applies rigid scaffolding to ensure its use forces students to think harder, evaluate more deeply, and defend their positions more rigorously. Securing the future of higher education requires designing resilient pedagogy that embeds these tools into the heart of the learning journey.